Square root. In order to have a deep understanding of a square root, we need to review the concept of factoring. What does factoring mean? Let's say we have two numbers. 3 times 2 equals 6. 3 is a factor. 2 also is a factor, and 6 is a product. Factors are the numbers you multiply together to get another numbers. Let's say we have 2 times 4 equals 8. The factors of 8 are 4 and 2, because if we multiply them, then you get 8. However, these 2 and 4 are not the only factors. It could be 1 times 8 equals 8, right? When you have two or more numbers times together, these are factors that produce a result, which is our product. So factors are the numbers you multiply together to get another number. So if somebody asks you what are the factors of number 12, you could say it is 1 times 12, or 2 times 6, or 3 times 4. All of them are factors for 12. What about 7? 7 only can be multiplied by 1, and so the factors are only 7 and 1. There is no other factors for that. That is why 7 is called prime factor. The prime factor means a number that cannot be multiplied or divided by any other number except 1. So there are a couple of prime factors that you know and you can remember it easily. It's 2, 3, 5, 7, 11, 13, 17, and 19. 1 is not regarded as a prime number because 1 goes into everything. Definition for prime number is a number that can multiply or divided evenly only by 1 or itself. So these are our prime factors. Then we have the concept of factorizing or factorization. Factorization in fact means decomposing. Is a process of breaking down a large number so that it gets easier to deal with. Let's say we have 24. We are interested to break down and see what factors goes to 24. So we see 6 and 4 are the factors. 6 can be break down to smaller numbers, and it's 2 and 3. Also 4 can be break down to 2, 2. So the prime factorization for 24 is 3 times 2 times 2 times 2. This diagram is called factor tree. Let's work with 36. We start our factor tree by thinking of what factors goes to 36. 9 times 4 is 36. 9 can be divided, or factors that goes to 9 are 3 and 3. Factors that goes to 4 are 2 and 2. So the prime factorization for 36 is 3 times 3 times 2 times 2. What about 149? Can we start divided by 2? No. We should pay attention to the last digit or the last two digits. Since it's an odd number, it cannot be divided by 2. So we start by the next smallest prime number. So we divide it by 3 and we get 49. We can divide 49 by 7 and get 7. So the prime factorization for 149 is 3 times 7 times 7, or 3 times 7 squared. What is prime factor of 17? It doesn't have a prime factor. 17 itself is a prime number. What about 90? 90 can be divided by 9 and 10. 10 can be 3 times 3, and 10 can be 2 times 5. So prime factorization for 90 is 3 times 3 times 2 times 5, or 3 squared times 2 times 5. Now we are ready for the concept of a square root. Let me clear the board first. The square root of a number is a number which multiplied by itself give you the original number. It has a symbol. It's called radical. And the numbers that goes under this radical is called radicand. Let's say we have radical 9. The square root for radical 9 is 3, because 3 times 3 equals 9, right? So the square root for radical 9 is 3. The square root for 16 is 4, because 4 times 4 is 16. The square root for 25, as you can guess, is 5, since 5 times 5 equals 25. Or square root for 49 is 7, because 7 times 7 equals 49. Another way to explain it is to consider that we know that every operation in mathematics has its own inverse. Subtraction is inverse of addition, or division is inverse of multiplication, right? So when we say square a number, it means that number times itself. Finding a square root means doing the inverse operation of a squaring. Let's say we have 5 times 5, or 5 squared, which means 25, right? And the square root of 25 is 5. Or 10 times 10, 10 squared produce 100. When we say square root of 100, it means 10. There are some numbers, we call them perfect square. The perfect squares are the squares of the whole numbers. Why do I say whole number? Because when it is not perfect square, it will be a decimal. The perfect squares are the squares of the whole numbers. We have to remember that. I'm going to list some of the square numbers and their perfect squares for you here to see. Let's say square numbers, which are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think it's enough for now. Maybe we add one more here. And perfect square are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 196, and so on. You can find the table for perfect square online, and that makes your work easier. However, radicals are not always perfect squares, therefore needed to be simplified. How could we simplify a non-perfect radicals? We can do it by factoring. First, we need to factor out the largest possible perfect square, then simplify the radical with the perfect square. Let's say we have radical 50. So, to simplify that, we know that 50 is 225, right? So it means we have 5 times 5 times 2. Or we have 5 squared times 2. Let's say we have 36. What positive number is squared to become positive 36? We know that 6 times 6, or 6 squared, equals to 36. Let's say we have 225. 15 times 15, or 15 squared, is 225. Sometimes it's not easy to find the perfect square, so what we do is we start with 4, the first perfect square, and go through all perfect squares to identify the largest factor of the radicand. Let's say we have 40. So we know we have a radical 4 times 10 in 40. So a square root for 4 is 2. We take the 2 out of radical and we leave the number 10 as radicand. And this is as far as it could be simplified. Then we have, let's say, 27. We don't have a perfect square for 27, but we have 9 times 3. So the square root for 9 is 3. We take it out of radical and leave 3 there. Let's say we have radical 20. We have radical 4 and radical 5. Square root for 4 is 2, and so we have 2 radical 5 remain. Radical 18. We have radical 9 times radical 2. We take the square root out and leave the radical 2. Let's say we have radical 125. We know that there is a perfect square for that, which is 25 times 5, and then we take the square root out. 5 radical 5 will remain. Sometimes we have a number in front of radical. 2 times, for instance, 28. What do we do now? In case such as this, we first need to simplify the radical, then times it to 2. So we leave it like that. 2 radical 4 times radical 7. Square root of 4 is 2, so we have 2 times 2 radical 7. So we have 4 radical 7. Square root of 200. Sometimes we have several perfect square for a number. In that case, it doesn't matter which one we use. Choose one of them and factor it out and find the fastest way. Let's say in case of 200, 10 times 50, or it can be 25 times 8, or even it can be 100 times 2, right? Since 100 is the largest one, we choose that one. Radical 200 will be radical 100 times radical 2, and we know the square root for 100 is 10, so it's 10 radical 2. But let's say we didn't pick the largest, or 100. What could have happened? Nothing could have happened. Probably you needed to take further step to get to the result. Let's say for radical 200, we picked radical 25 times radical 8. The square root for 25, it's a perfect square, is 5 radical 8. And we can simplify this one as 5 radical 4 times radical 2. The square root for 4 is 2. So 5 times 2 radical 2. The result is the same, 10 radical 2. What if we have a negative radical? Let's say we have minus radical 98. The sign would remain there, and we simplify our radical. It could be 49, which is a perfect square, times 2, and then we have minus 7, which is the square root for 49, radical 2. Let's say we have radical 80 over 2. In that case, we simplify for radical 80 and then we do the operation. Let's say for 80, radical 80 can be simplified as radical 16 times radical 5 over 2. And then you have the square root of 16 is 4. To take it out of the radical, and the remaining is radical 5 over 2. Now we can simplify the fraction and have 2 radical 5. Let's say we have two radicals, radical 9 and radical 25. And you're asked to multiply these two radicals together. What do we do now? First, we find the square root for each of them. The square root for 9 is 3, and square root for 25 is 5. We multiply it, we get 15, and we are done. I think you are ready to do some practice at home. So simplify the following radicals. Radical 32, radical 75, radical 45, radical 90, radical 625, radical 600, radical 128, radical 18 times radical 25, radical 90 over 6, radical 275 over 5. So we are at the end of our session on the square root. Try to keep practice at home.